Hello guys. Yeah, okay, we're going to deal with the rationalizing. So we are going to rationalize. We're simply going to rationalize irrational values, or those that we find as irrational. We're going to convert them to rational numbers. For example, we can have it in two ways. The question might say rationalize the numerator or rationalize the denominator. So, but the procedure is the same. So how about the rationalize the numerator? For example, e.g., if you have this question here, root 1 that, yeah, root 2 over 1 plus root 2. Rationalizing the numerator, we want to make this number to be rational, and for it to be irrational, we have to square and remove root 2, right? So we are simply going to multiply by root 2 above and beneath. So it is a manipulation in maths, which is just multiply by 1. I get multiplicative identity. So multiply by root 2 above and beneath. So therefore, root 2 times root 2 is going to be root 2 squared. And then 1 times root 2 is going to be 1 root 2. And root 2 times root 2 is going to be root 2 times root 2, which is 2 or root 2 squared. Either way you want it. And then this power 2 will cancel root, because root is equivalent to power half. Therefore, we are going to only remain with 2 to the power 1, which is 2. So it's 2 over 1 times root 2 is simply root 2, and root 2 squared is 2. Then that will be your answer. And then the second one, we can have root 3 minus 1 over 2. So that is multiplied by the conjugate of the above. Remember, we want to make the above to be a rational number. Therefore, we simply change one of the signs. Even if you can change this sign here and put a minus there, still it will give you the answer, but it's always best to change that which is a minus. So, or just change the sign of the second time most of the time. So change the sign to be a positive. So therefore, you are going to have root 3. Wait, remember the question was root 3 minus 1 all over 2. And then we're going to multiply each, the numerator and the denominator by root 3 plus 1, root 3 plus 1. Expanding. If you look at this, they are all the same, and the signs in the middle are the ones which are different. So this takes us back to the property of difference of squares. For the difference of squares property, say that a squared minus b squared is equals to a minus b, a plus b. It says this. So it's the same. So from here, we can simply go there. So without wasting time, right? As long as you remember. If you don't remember, please expand one by one, right? That is, don't take risks, because a test is a test. A risk is, it means the mark is gone. So therefore, we're going to have root 3 squared minus 1 squared. And then all over 2 times root 3, it's 2 root 3. And then 2 times 1, it's going to be 2. So above there, we're going to have 3 minus a 1, which is a 2. Then just like that. And then it's a 2 above there. But even if we can factor 2 here out, we're going to have something good. We can have 2 outside, then cancel out 2. So 2 here, 1, 2 here, 1. Therefore, we have 1 over root 3 minus 1. So this will be our answer. I guess we are all good. And the next one, we can have something like, let me change color, something like 2 plus root 5. 2 plus root 5 over 3. So 2 plus root 5 over 3. We do the same. Change the sign of the second one as I advised you. So what I would, that will be the conjugate. So that is, we're going to have 2 plus root 5 over 3 times, or we can put brackets because it's 2 times is binomial. So we're going to have 2 minus root 5. And then above and beneath, 2 minus root 5. Above and beneath. And then multiply everything. So therefore, you're going to have 2 times 2. Remember, still, these things, we go back to that. We go back to that difference of squares, right? So therefore, it's simply going to have 2 squared minus root 5 squared. So it's going to be 2 squared minus root 5 squared. And then all over, let's see, maybe this 3 will be able to cancel it out. But I have a saying, or we have a saying, that don't mess with the numerator. No, sorry, don't mess with the denominator. Because oftentimes the denominator will help you simplify. 2 minus root 5. And then up there, it's gonna be 4 minus 5. It's gonna be 4 minus 5. 4 minus a 5. 4 minus 5, because okay, 2 squared is 4, and this root will be cancelled by power 2, so we're going to remain with 5. So, and then beneath, you're going to have 3, 2 minus root 5, right? And then you're going to have negative 1 over 3 times 2 minus root 5, right? This is nothing, please. The thing you see there, it's nothing. Don't worry about it. And then you close the bracket. So that is, let me write it properly. 3, 2 minus root 5. So this will be our answer. Very easy. I guess we can see that. Very easy. I guess we can see that. Our final solution will be that. Where did it go? I don't know. Okay, yeah, here it is. This will be our final solution, fellows. So then we're done. Voila. Okay, let's check for the second example, or fourth, I mean. Fourth. As for the fourth example, you can have both of your numbers. You can have both of your numbers as irrational. We put a plus, maybe. That's supposed to be a true. No, it's supposed to be something big, challenging, and lovely. Yes, so let's put 3 all over 5, I think, or 7. Either way, it looks like I'm using 5 a lot. Let me say 9. Sorry about that delay. Okay, yeah, 7, it's good. And then here, in the conjugate of the above, same, change the sign of this one. Change the sign of this one. So then you're gonna have it as root 2 plus root 3. Everything times root 2 minus root 5. Sorry, minus root 3, right? Minus root 3. Bracket, remember it's binomial. Expand everything. Then 7 times root 2 minus root 3. Bracket still. And then remember, this is simply difference of squares. So you simply square this one minus that squared. So therefore, we're going to have root 2 squared minus root 3 squared all over. I said do not mess up with the denominator, so let's leave it as it is. So it's going to be root 3, sorry, it's root 2. So it's root 2 minus root 3. Simplify above there. Power 2 cancels root, power 2 cancels root. So you're going to get a 2 minus 3, sorry, over 7 root 2 minus root 3. So then make sure that the division sign goes over everything that you wrote, please. So then you're going to get negative 1 over 7 times root 2 minus root 3. That will be your answer, right? That is it, fellows. Very easy. Life is easy. Eating is even hard. Okay, number 5. You can maybe have it there as a, what is a, maybe it's a minus or something like that, but sometimes it's very easy. Let me see. Okay, root. You can have a little bit hard one. You can have a little bit, one which is a little bit hard. We can have, okay, cube root of 2, cube root of 2, cube root of 2, cube root of 2 over 1 plus root 2. This one. Rationalize the numerator. So here what you are going to do, fellows, I guess I have your attention, all of you, because this is the critical part. This is the critical part. It's one sign that you have understood the topic if you can solve this one. So we have these, fellows. So what we are going to do here, remember our aim is to have the above as a rational number. So there we have cube root of 3. Cube root of 3. We have cube root of 3, fellows. We agree on that? Yes, we do. Cube root of 3. What is our measure aim? Our measure aim is to have the above as a rational number. Therefore, how can we have a rational number if we go back to the topic of indices? That means if we power by 3. If we power this by 3, remember that cube root of, let me just write here our cube root of 2, cube root of 3, for it to become what do you call it, a rational number, we need to cube it. So it'll be there. Sorry about that. So we need to cube it. We need to cube it. I mean, we need to write it as 2 to the power 1/3 all to the power 3. And then these things are going to multiply each other. And then 3 here, 1, 3 there, 1. Then we'll have remained with 2. And 2 is a rational number. That is our aim. So it's cubed, but cubing above and beneath is not going to help us. But what can help us is when we apply cube by multiplication, not by ordering. That is multiply by √2 3 times. So, okay, now I'm rubbing this part, which I was just showing you in the whatever, how we got there. So, okay, let me try and run. I'm going to be a bit slow, and I'm sorry as always. Yeah, so we're here. Oh, I should have wrapped this. So now, our measure aim, remember it was to cube, but we cannot cube, because if we cube above here and cube beneath here, we are not going to be doing the same thing above and beneath. Maybe yes, but not. In this case, the shorter way is to multiply by this number 3 times. We already have it once, so we should have it second, and then the third time. Like so, there are 3. So it's the same way that I did here, and I rubbed, right? So therefore now, beneath here, still we're gonna do the same thing, multiply by the same numbers. Remember what you do in the numerator, we do in the denominator. So then we're gonna have cube root of 2 times cube root of 2. Above there, simplify. Cube root of 2 cubed. Cube root of 2 cubed. Cube root of 2 cubed. Yeah, cube root of 2 cubed over. Here's gonna be cube root of 2 squared. So it's gonna be 1 plus √2 times cube root of 2 is a 3 squared. Right, and then above there, power 3 will cancel 1/3, so we're gonna have 2 above there. So we're gonna have 2 over, beneath here we have this, we can distribute this times that. So we are going to have 1 times cube root of 2 squared. So it's gonna be cube root of 2 squared, cube root of 2 squared, cube root having a smaller than 3 there, right? And then plus √2 times that. They are now we're going to simplify. So are they? Yes, they are, but let me put them close together. That is going to be square root times cube root of 2 squared. Remember, simplifying them in indices, we know how to simplify them, right? Or just maybe leave the denominator as it is. It's up to you anyway. So not leaving it as it is. Remember, here we have power half, and here we have power 2/3. So adding those things, I don't know how much they're going to give you. So should I leave it here? Let me try to finish it for those that are curious. Okay, plus here we're going to have, this is power half, remember, and this is power 2/3. So half plus 2/3. So it's simply how we're going to do it. Half plus 2/3 plus 2/3. So it's going to be 1/6 or 7/6. So it's going to be 7/6, which is 7/6. That is 6th root of, sorry about that, such a weird number. 6th root to the power 7. But I advise you to leave the denominator as it is there. So anyway, that will be our answer. Please, I made it look like it's hard, but okay, please, let's forget this. Let's forget this, fellows, because it will confuse you, or it will make you to think it's hard. So your final answer should be 2 over this, which is cube root of 2 squared, cube root of 2 squared times 1 plus √2. Easy. So that is it. I know we are all happy then. So it will be just as easy as that. And then the next one, let's see how we can go for our next example. Okay, have a last look at it. Look at it for last time. And then we can maybe have it as, I think, even when it's not a single term, but many times, we're just going to do the same thing, multiply by it 3 times. Have it as 1 and then 2, then 3, so they can cancel out, right? That is how it's going to be done. So that is how easy it is. I think it's easy, just that we have not accepted that it's easy. So now we're going to have its denominator. We're going to have rationalizing the denominator, rationalizing or making the denominator to be a rational number. So I'm just going to do one example, please, because wow, we are all good. So we're going to have something like, okay, we're going to have something like 2 root 2 minus root 3. What you do here is the same thing that we did that side. What we do here, we are simply going to take the conjugate of the denominator, because our major aim is to make the denominator to be rational, remember. So therefore, we're simply going to multiply by the same number. So it'll be cube root of 2 minus root 3. So the conjugate of the denominator, still you change the sign of, I advise you to change the sign of the last one. So we change the sign and we're going to have a positive. So that is going to be root 2 plus root 3 over root 2 plus root 3. Multiply everything by those. Above there, maybe you can expand or leave it. It's up to you. But expand it's always good, because you can maybe simplify at the end. But if you see that it's not necessary, do not expand. So 2 times root 2, it will be 2 root 2, and then 2 times root 3 is going to be 2 root 3. So very easy. Beneath there, still we apply the same property, difference of squares. The first one squared minus the second one squared. So you're going to get 2 root 2 plus 2 root 3 over 2 minus 3, which is a 1. No, a negative 1. 2 root 2 plus 2 root 3 over negative 1. Then this negative 1, you can distribute it, and then your answer can be negative 2 root 2 minus 2 root 3. Then this will be your answer. We're good. I guess we understand. That is simply what we'll be doing about rationalizing. It's really easy stuff. It's really easy stuff. So nothing is really hard pertaining this. So let me see the next example, what I'm going to do. Oh, yes, fellas. So we're moving to another objective, which is, maybe it's a big objective, or we should say it's a topic. Like this one, it's factoring expressions, that is under algebra. So we have this factoring. This one, it's called difference of squares. I should use a different ink, I think. Difference of squares. Difference of squares. And then this one is called a perfect square. And this one here, it's called a difference of cubes. Difference of cubes. And then supposed to be 1e. And then this one, it's sum of cubes. Sum of cubes. Sum of cubes. So therefore, for a difference of square is whereby we have a number squared minus a number squared, or these might be variables or whatever, but when you expand them, when you factor them out, you are going to have the first number minus second number times first number plus the second number. So that is how it works. You can check for examples. They will all prove them to be true. And then perfect squares, we have perfect squares, they have a positive sign like this plus here. So if it's a plus here, if we have a squared plus 2ab plus b squared, we are going to have the factoring part as a plus b squared, a plus b squared, and or you can have it as a plus b times a plus b. So that is it. And then if it's a minus, if you have a squared minus 2ab plus b squared, we are going to have a minus b all squared, or a minus b times a minus b, right? We said they're perfect squares because their factors are perfectly the same. So we can write it as one factor, then put a power order. So, and then difference of cubes, if we have a number cubed minus a number cubed, we are going to have our first small factor as the first number minus the second number. If at all it was a minus, right? If at all it was a minus, you're going to have it there. So remember the sign that you have on the question, is the sign that you're going to have on the smaller factor, right? And then on the bigger factor, this sign is going to be opposite of the sign that you got. So then the bigger bracket is going to be a squared plus ab plus b squared. I guess we're good. And then if it's a plus, if we have a cubed plus b cubed, we're going to have the smaller factor as a plus b, a plus b, a plus b. And then this one, it's going to be a total opposite of that one. So it's going to be a minus, and all things the same, or everything the same. That is, it is going to be a squared minus ab plus b squared. So this is it. And one more thing that you can have is what? This is it about factoring. So we can have examples here and try to prove whatever. So let's try to be having examples. Okay, examples. I'm going to go by line or by that order. Things right now we but okay. I'm new in these things. No? Okay, examples. Examples. Still, it's one question. It says factorize. Factorize. Number 8. Or should I say 1? Okay. Number 1. Okay. It's a 1 there. Number 1. X squared minus 9. Okay. This is x and it's squared, and then this is a 9, and 9 is a square number. Therefore, you can simplify 9 and write it as a number squared. So that is going to be x squared minus 3 squared. And then they're all to power 2, therefore, they qualify to be difference of squares. So therefore, we're going to say, remember how it looks like difference of squares? It's going to be x minus 3 and x plus 3. Then this will be your factor. Good to go. Very easy. Number 2. Can have something like 2x all squared minus 16. So this one, same applies. 2x, they are all under a square, and 16 is a square number. We can write it as 4 squared. That is, you're going to have, okay, 2x all squared minus 4 squared. They're both 2 squared, then you can collect. So you're going to have 2x minus 4 times 2x plus 4. I guess we're good with that. And maybe you can factor out, 2 from both, and then you're going to have 4 outside. So same applies. So someone can factor 2 from this one and have 2 bracket 2 into that, it's going to be x, and 2 into that, it's going to be 2, and then 2 again there, and say 2 into that, it's going to be x, 2. So and then 2 and 2, they'll give you 4. I get it. Whatever then your answer is going to be, your answer here, it's going to be 4x minus 2x plus 2, right? In which alternatively, let me use red ink. Alternatively, you can simply say here, as it is, you see you have a 2 squared, so it's going to give you a 4, and we have a 4 already inside there. And again, 4 is a square number on its own. So therefore, you can simply expand this. Okay, 2x all squared minus 16 can be written as 2 squared x squared minus 16, right? Which is 4x squared minus 16. If you factor out 4 from everything, you're going to remain with 4. 4 into x squared, it's going to be x squared, and then 4 into 16, it's going to be 4. And then we can write it as 4 times x squared minus 2 squared. And then we can operate our operation there. It's going to be 4 of x minus 2 x plus 2. I guess we're good. So this will give us the same answer as that one, right? Yeah, the same. So yeah, I guess we're good. I think I didn't leave anyone behind. All right. That is difference of squares. We can have it as okay. I saw a very good example here. Someone sent it to me in my phone. Let me do it. It's kind of hard but interesting, you know. Hard but interesting. I'm sorry. Say that. Okay, something like example number 3. Something like 9y squared minus 4 times. Let me just stop here for this one. Let me not go far. I'll add these other things. I'll do it again, but adding those other things. So when it's like this and you have to factor it out, what you're going to do, okay, we have 9 is a square number and 4 is a square number, so we can write them in terms of power 2, right? So we can have 3 squared y squared minus 2 squared. So therefore, that is going to be 3y. Please group them and make them to have 1 square, those that are bounded by multiplication, 2 squared. So then when it's like this, you can simply say 3y minus 2 times 3y plus 2. And that will give you your answer. I'm sorry, I have to switch off this phone. Yes. Okay, you can simply have it as that, and then that will be your answer, right? But it can be a little hard. Let me say this was 3 Roman figure 1, 3 Roman figure 2. In worst case scenario, okay, not worst case anyway. Minus 4 times, what was this? X plus y. I think it was x plus y. Yes, x plus y squared. X plus y squared. So when it's like this, 9 is a square number. Maybe I should change and not write 9, write a certain number. let me put, how much should I put? Let me see. Yeah, 25. I'm gonna put 25. 25. Yes, 25 that. So whatever, this is a square number, this is a square number, this is a square number, and that is a square number. So they are all square numbers. So we have to find a common way of writing them by power 2. So therefore, we are simply going to have 5 squared y squared minus 2 squared times x plus y. I get, you know, addition is commutative. That I get. So they're both squared. So make sure we factor or you write them in terms of 1 square, 1 square. Combine this and make them have 1 power, and combine those and make them have 1 power, right? That is our major aim now. So we're going to have 5y all to the power 2 minus 2 times x plus y all to the power 2. And then we are good. Don't be scared of how big it is inside or whatever, but just do what you know. Take what is inside, refactor, that is 5y minus 2 times x plus y, right? And then the other part is going to be 5y plus 2 times x plus y. And that will be your factors. Maybe you can further simplify them by these brackets and remove brackets. First bracket, you're going to have 5y minus 2x minus 2y. If you have to simplify, and then second bracket, you have the same thing, 5y plus 2x plus 2y, simplifying those. So 2y and 5y, they simplify to 3y. So you're going to have 3y minus 2x. The other bracket is going to be 7y plus 2x. Anyway, this will be your answer. Or even if you stop here, it's fine because you have factorized, you have done your goal. These ones that I'm doing to simplify what I say, you were not asked to simplify, unless if they say factorize and simplify. But this should be enough. Yes. But if you are confident and you feel like you can go an extra mile, you can end up having the answer beneath there. So I guess we are good, right? I wanted to label that answer with a different thing. It's not labeling. Okay, now it's fine. So I think we are good. I'll continue referring to what I was given to get a little bit harder examples of this concept. So let me see what I'm given again and that I can take and give you. Yes, we have this other interesting one. We have 8 cubed minus 8. No, x cubed minus 8. So this is 4 x cubed minus 8 divided by x to the power 4. So we did x to the power 4 minus, we have the question. It looks like this. It's this one here. What happened? Is this one here. Factorize and simplify. So what you're going to do is just easy. Make sure that you write everything in terms of, okay, here we have x cubed minus 8, and 8 is a cube number. Write it as a number cubed, right? It is going to be that, and then beneath there, we can write it as a square. So it's going to be x squared, the square outside, like that. And then they have this one, it's a trinomial, we have to deal with it. I'll show you just a bit after this on how to do it. And then here we have 8 again, write it as a number cubed. So now here I was trying to split them. Let me just take it to red color. So I was trying to split them. We have the first one, it's there. The second one, it's here. Third one, it's here. And the fourth one, it's here. And then from here, we are simply going to substitute by our expanded things. So that means that everything is equals to the first one. We had x cubed minus 2 cubed. So it's going to be the above there. So it's going to be x cubed, x minus 3, then times x squared plus 3x plus 3 squared, which is a 9, right? And then beneath we had that x to the power 4 and 16, so which is can be simplified like that. So which will be x minus 2, x plus 2, x squared plus 4. Remember, it's divided. We should have flipped them first. So above there we have this one. So it's going to be x plus 2 all squared, and then divided by this one, which has plus 8, which is the beneath one, which will be x plus 2 x squared minus 2x plus 4. Now, because of division, remember that when you divide fractions, we flip the last fraction and multiply. I guess we remember that. We flip the last fraction and multiply. Therefore, we are going to have x minus 3 times x squared plus 3x plus 9 over x minus 2, x plus 2, and x squared plus 4 times, remember we flip the last fraction and multiply. But this part or this portion goes up, which is going to be x plus 2 times x squared minus 2x plus 4 all over x plus 2 squared. And then simplify. And then, what did I forget? This part which has a 3, I think I made a mistake. Fellows. I think I made a mistake. This is not 3 but 2. This is not 3 but 2. It should be a 2 here, right? And then here it should be a 2, and then here it should be a 4. That is the mistake I made. Same applies in the questions. Yes, it should be a 2, even here. Here it's a 4, a 4, and yeah, that is the mistake I made. A 2, a 2, and a 4. Let me wrap that which can be wrapped. Right. I think I didn't. Yes, I think I got everything right. Okay, so it's going to be a 2 here, and then 2x plus a 4. 2 here, 2x plus a 4. And then we try to cancel out that which can be cancelled out. So it's advisable to use a different ink. So here we have a minus 2. X minus 2 goes with x minus 2. I believe we are good with that. And another mistake here, you tutor or error. So all the best. This cannot be factored. This cannot be factored, which is the part above, which is this part. This part cannot be factored. So it was supposed to remain as that. It was supposed to remain as that, and then it went down, remember? So it was supposed to be like that. So my bad, I made a mistake. So it's supposed just to remain like that. So it's gonna be x squared times 2x plus 4. I thought this is a 4, that's why I simplified it that way. So then on this page, whatever, this cancels with that. I hope you saw all the corrections. But at the end of the day, your thing after expansion should look like this. It should be x minus 2 times x squared plus 2x plus 4 over x minus 2 times x plus 2 times x squared plus 4. Everything multiplied by this portion. Calling them, hey, to make me to feel tasty. Huh? Now, we are now here. So this portion is the same as that portion, so they can divide each other. This portion here, 1. This portion there, 1. Okay, should have cancelled it. Yes, it's 1, right? And then we remain with this and that. This here, 1. This here, 1. Then you remain with this and that. Therefore, your answer is x squared minus 2x plus 4, everything over x squared plus 4, because it cannot be simplified. That will be your answer. Okay, please don't let this to confuse you. This is one in here. Yes, we're good now. That will be your answer. This will be your answer there. Then you get your answer. So now I'd like to talk about something that I didn't talk about before. That is factoring trinomials. Factoring quadratics. If you have a quadratic which is looking like this, then you have to factor it. You have to consider two things: ax squared plus bx plus c. You have to consider two things. One, it's called product. Product is always formed by the coefficient of x squared, or the coefficient of the variable that is being squared, that is a, then times the constant term, which is always c. So what our product is ac, right? And then the sum. The sum is always going to be the coefficient of that number which has a variable to the power 1, which is x in this case. So sum will be b. And then we are going to find our factors. And our factors, we're going to find them in such a way that when you multiply them, they give you the product. That is why we say they are factors. They are factors of the product. And when you add them, they should give you b. I guess we are good in that. So example, just the one that we had. X squared plus 4x plus 4. What is the product? Oh, sorry, it shouldn't be an equal sign, but rather maybe that. Product, it's going to be number 1 times 4. 1 times 4. Remember, point halogodum is considered multiplication. So it's a 4, right? And then the sum, it's a 4. We are looking for multiples of 4 in which when we add, they give you 4. What are those? True and true, positive, right? Factors is positive 2 and positive 2. So now we are going to remove our sum here and replace it with these factors in which when you add, they give you the sum. So it's going to be 2x, 2x. So therefore, we are going to replace that by x squared plus 2x plus 2x plus 4. And then you factor the first two terms. Now I put these brackets because they do not affect the sign. If you can put these brackets, if you can put these brackets, they're going to make your answer to be wrong, given a case. So that is minus, which will not be true at that time. So therefore, that's why I advise people to always use the square brackets to show their marking. So I guess we are clear on that. So hey fellows, I'm not perfect, I'm not perfect. So wherever you feel like I didn't do something well, please just comment below and I'll fix that problem. I'll fix that problem. We are learning. We are learning. Yeah, so then we are here. What is the number that we can remove from the first two terms of that number which is common? Simply x. So x outside and then x into x squared, it's going to be x, and then x into 2x is going to be positive 2. What number can we remove from here such that the remaining thing which is going to be in the brackets should be the same as this one? The number is positive 2. 2 into 2x, it's x. 2 into 4, it's positive 2. And then since those that are inside the brackets are the same, collect those that are outside and let them form a factor, which is x plus 2. From outside, they form a factor, and then collect one of those that are inside. And these ones are the same, so you can group them and have x plus 2 squared. Then that will be your answer. So this is how easy it is. Let me see if at all I can have another one. You can have another one of a similar type. Something like let me see. Please bear with me because your boy here is not prepared. Let me see. Okay, something like, I think it will work. It's just from my head. It's just from my head, but I think it will work. I trust myself. 2x squared plus some number x minus 10. Minus 10. Oh, no, sorry. Minus 5. Hey, yeah. Even a 10 we can write. Minus a 10. So, okay. Let me say 8. Okay, what is the product here? The product is going to be 2 times negative 10. It's going to be 2 times negative 10, which is negative 20, right? Then what is the sum? The sum is going to be positive 8. Positive 8. So therefore, now the question is, what are factors of negative 20 which can give you 8 as a sum? Which can give you positive 8 as a sum. So you list all factors of 20, 1, 20, and then 2, 10, 4, 5, and so forth, if at all they are. And then you say that, and then you say, I got a negative 20, so in order for it to be negative, that implies that one of the numbers or one of my factors should be negative. So either of them can be negative. But if the sum is positive, it simply implies that the smaller factor is the one which is negative. So then those factors are going to be negative 2 and 10. Because when you add negative 2 and 10, you get a positive 8. Therefore, take these and plug them for 8. So that implies that you're going to have that minus 2x plus 10x minus 10. Then you factor out First two terms, last two terms. What's common in the first two terms? 2x. 2x is common. 2x into 2x squared, it's x. And then 2x into negative 2x is negative 1. And then we can remove 10 from there, you're positive. Then 10 into 10x, x 10 into 10 is 1. And then those that are inside are the same. Therefore, we collect those that are outside. So we have 2x. Yes, we have 2x plus 10 times x minus 1. Remember that the question will be saying factor completely. So here we have a 2 common, right? We can pull it out. So that is, we're going to have 2 bracket 2 into that, it's x, 2 into that, it's 5. And then, I'm sorry, it should be a minus. It should be a minus 1. So it will be like this, I get it. Or just from the beginning, you can simply 2, it's here, you can see it, it's here, you can put it out. And then have it coming down just like that until it arrives here. So then at this stage, you will have done your factoring completely. So then I'm going to stop here and let me look at some questions. I'll come back and upload. Let me just upload this. Thank you so much for your patience, and I'm sorry for the